Okay, I am next to share screen. Okay, by using this operations, additive operations and multiplicative operations, we are doing two problems here in the exercise 1.2.1. Show that we are a plus b is equal to a plus c implies b is equal to c. Here this is the 1.2.1 problem. A plus b is equal to how much here? A plus c. Here given, first of all, first step is a plus b is equal to a plus c. Adding both sides by minus a. We are adding both sides by minus a on left hand side. Left side minus a minus a. It is left side adding and changing the bracket minus a plus b is equal to minus a plus a plus c. We are getting here minus a plus a is equal to 0 plus a b is equal to 0 plus c. Here 0 plus b is equal to b and 0 plus c is equal to c. Therefore, we get b is equal to c. Here, this is the first property. First property name, second property, and this is the third property. Here we are using minus a, means universal property we are using in addition. And the second one is here brackets are changing, means here using associative property. And here minus a plus a is equal to 0 we are getting. This is the identity property. This is the identity property. Therefore, we are getting how much here? B is equal to C by using before definition of real numbers as an ordered field. This is the first problem. And next second problem here 1.2.2 show that here a plus a is equal to a implies we must show here a is equal to 0. Okay, here given, first of all, taking here given problem is a plus a is equal to a. Here adding both sides by minus a. Adding both sides by minus a on left side. Okay, we are taking on left side. Minus a plus of a plus a is equal to minus a plus a. This is the step. Okay. Next one, here brackets are changing minus a plus a is equal to here minus a plus a. Okay. Minus a plus a gives 0. Next step. 0 plus a is equal to how much here? 0. Therefore, 0 plus a is equal to here 0 plus a is equal to a. Therefore, we will get a is equal to 0 in the box. Okay. We are using the properties here. What are the properties here? First property. This is the second property. And this is the third property. Here, first property is what here? First property is here universal property. Minus a are using in this problem. Okay. And the second property is here brackets are changing. Therefore, here associative property are using. And the next third one is minus a plus a is giving 0. Here it is a inverse property. It is a minus a plus a is equal to 0. A inverse is minus a inverse is a. Therefore, it is the inverse property. Therefore, it will give 0. Okay. 0 plus a is equal to 0. Therefore, we will get at last a is equal to 0 in this problem. Okay. Are you understand? Are you understand?
Yes, sir.
Yes, sir.
Yes, sir.
Next one. Next screen. Here one more. Here the real number system having 6 more properties are there here, and the page number we are showing. Here first property is one more property, a into b. Here taking here a into b is equal to how much here? A into b is equal to 1. Implies here a is equal to 1 by b, here b not is equal to 0. Implies a is equal to b inverse. Here b is not is equal to 0. Means here a is equal to b inverse. It is inverse property. A into b inverse. A into a is equal to how much here? To take here, first of all, here a into b is equal to a is equal to how much we got? B inverse into b. A is equal to how much here? B inverse. B inverse into b is equal to how much here? 1. Therefore, we are taking a into b is equal to 1 directly. A into b is equal to 1 means a is equal to b inverse. This is the property we are taking here. And next one, second one. Suppose A is not is equal to 0. A is not is equal to 0. We will get how much here? A inverse also not is equal to 0. By using these two, A inverse whole inverse is equal to A. This is the second property of a real number. Another property. The next one, third one is minus 1 into A is equal to minus A. And fourth one is minus A into B is equal to A into minus B is equal to minus AB. This is the fourth property. And the fifth property is minus A into minus B is equal to plus AB. This is the fifth property. And the sixth one is ordered relation. This is the ordered relation means here less than or equal to called here ordered relation. A and B are any two real numbers here. And A less than or is equal to B or B less than or is equal to A. A is less than or is equal to B or B is less than or is equal to A. This property less than or is equal to called ordered relation on R. This is the another property. We are saw in the previous image, we have saw 9 properties. These 6 properties are extra properties. And next, I am sharing next screen. And the next definition, we are taking here definition. A non-empty subset P, a non-empty subset here P. We are taking here P is a subset of real numbers. P is a subset of R. Here a non-empty subset P of R called the set of strictly positive real numbers. Strictly positive real numbers. This P is called strictly positive real numbers. Real numbers. P is called strictly positive real numbers. R is called real numbers. P is strictly positive real numbers. Okay. First property is here A comma B belongs to R. A comma B belongs to P here. A comma B is belongs to P. Then here adding these two numbers A plus B. It is also gives strictly positive. Therefore, it is belongs to P only. Okay. Here A is belongs to strictly positive and B is also strictly positive. Where the operation is A plus B is also strictly positive. This is the first property. Okay. Next one, second one is A comma B is belongs to P. Means here second property. Here A belongs to strictly positive and B belongs to strictly positive. Here A into B is equal to, here A into B is equal to AB is belongs to P is also strictly positive. This is the second one. This is the second one. And the third one, if A belongs to a real number, not P. Here A belongs to a real number. A belongs to real number. Then one of the relation hold. Okay. A belongs to P is strictly positive, or A is equal to 0, or minus A means is strictly negative. Okay. Strictly negative real number is belongs to P. A belongs to R, not A belongs to P. Here A belongs to real number. Then it satisfies only one. Here A belongs to strictly positive, or A is equal to 0, or negative, strictly negative number, strictly negative real number, minus A is belongs to P. Only one is hold by giving A belongs to R. By giving A belongs to R. A belongs to R అని ఇచ్చినప్పుడు ఈ మూడిట్లలో ఏదో ఒకటి మాత్రమే మనము తీసుకోవచ్చు అని ఇక్కడ ప్రాపర్టీ ద్వారా చెప్తున్నారు. ఓకే, దిస్ ఈజ్ కాల్డ్, ఈ విధంగా రాయడానికి, దిస్ ఈజ్ కాల్డ్ లా ఆఫ్ ట్రైకోటమీ. లా ఆఫ్ ట్రైకోటమీ. దిస్ థర్డ్ వన్ ఈజ్ కాల్డ్ లా ఆఫ్ ట్రైకోటమీ. ఓకే, నెక్స్ట్ వన్ హియర్ negative number is given. Therefore, we are writing separately. Capital N is equal to set of minus A such that A belongs to P. N is equal how much here? Set of minus A such that A belongs to P. Here I am writing N is equal to set of minus A such that A belongs to P. Okay, is called strictly negative real number. Strictly negative real number. Actually, capital N here, not confused. Here, capital N is a natural number. Capital N is here. Actually, capital N is a natural number. Capital N is here. Here. Capital N is natural number. But here capital N is equal to, here saying here negative real numbers. Here N is denoted here. N is only number system. Okay. It is not a natural number system. It is not a natural number system. Not confused here. Okay. Here only here saying capital N. Capital N is equal to negative real numbers. That's all. Not natural numbers. Okay. Next one here, N intersection P. Here N is equal to what here? Negative real number. N means negative real numbers. And intersection P means positive real numbers. N is strictly negative numbers and P is strictly positive real numbers. It will use what here? Not common. No number is common here. Therefore, it will use 5 only. Here it is positive numbers. 1, 2, 3. Here, sorry. Here negative numbers, -1, -2, -3, and so on. Here the set intersection P means strictly positive numbers, 1, 2, 3. There is and so on. Okay. There is no common element. It will use only 5. It will use only 5. This is the definition. This is the definition. Okay. Next one. One more one here. Capital R is equal to, here saying capital R is equal to, N means here strictly negative numbers, union, set of zeros, union P here. N is the strictly negative numbers, union, set of zeros, union, here strictly positive numbers. It will use what here? R. It will use here R. This is the definition and some notations. And next one, next screen open. Okay, next some more notations are there here. Here A belongs to P. Suppose here I am taking A belongs to P. Some more notations are there. A belongs to P. We write A greater than 0. Here A is a positive, strictly positive. Here A is not given any negative number. Here it is a positive number. Why? Because P is a strictly positive number set, positive number set. We are taking one positive number A. We write in mathematical notation A greater than 0. A greater than 0. Suppose the condition is A belongs to, here A belongs to P and union set of zeros. Union set of zeros. Here P means here strictly positive number set. Taking one number A is union, A union set of 0 is equal to, the mathematical notation implies A greater than or is equal to 0. A greater than or is equal to 0. Okay, this is the mathematical notation. This is the first notation. Okay, next one, second notation. Minus A belongs to P. Minus A belongs to P. Minus A belongs to P means here P is the negative, strictly negative real numbers. Strictly negative real number set. We are taking one number minus A. We are taking one number minus A. We write it is a negative number. Therefore, A less than 0. Right? It can be.
Sir, your voice is low, sir.
Less than 0. Next one here. Minus A is belongs to P. Union set of 0. Okay. Here means it is minus A is a negative number. Union set of 0. We can written as here A is less than or equal to 0. Here not set of 0, it is A less than 0. It is union of set of 0. Union of set of 0, it is A is less than or equal to 0. This is the notation. Means here first property, first notation and second notation having, it is first notation gives A is greater than or is equal to 0. And the second notation is A less than or is equal to 0. First one is A greater than or is equal to 0. And the second one is A less than or is equal to 0. And the third one, A comma B belongs to R. Here A belongs to R comma B belongs to R. These are two numbers in real number system. Okay. And we are doing here A minus B. Means it is belongs to P. A minus B is belongs to P. Here P is the strictly positive real number system or strictly negative real number system. Okay. And A minus B gives here what here the mathematical notation is. Here A minus B means length. A minus B means here what here? Length. A minus B is here length. Therefore, we can write here A is greater than B. Why? Because here A is a positive number, B is a negative number. A is a positive number and
Sir,
B
your
is the
voice is low, sir.
negative
Say
number.
some loudly,
We can
sir.
write it A is greater than B. A is greater than B and here P is the strictly positive number. Strictly positive real number. Strictly positive real number. Okay. And next one, fourth one. Next, fourth one. Here A comma B is belongs to R. A is belongs to real number and B is belongs to real number. Then here implies minus A minus B is equal to how much it is minus A plus B. It is written as B minus A. It is B minus A is belongs to P. Here P is here a positive number. A is here negative number. We can write it A is less than B or B is greater than A. A is less than B or B is greater than A. This is the notation. This is the notation of A greater than B and B greater than A. And next one, fifth one, minus A minus B. Here A minus B is belongs to P union set of 0. We write A greater than or is equal to B. And next one, sixth one, similarly, minus of A minus B is belongs to P union set of 0. We write A less than or is equal to B. One more statement is there here. One more statement here, 1.2.6 here. By using a inequality statement, this one. Here let A comma B comma C belongs to R. Then first one, if A greater than B and B greater than C implies A greater than C. Here A is greater than B and B is greater than C. We can write it A greater than C. A is greater than C. And this is the first one. And second one here, A is greater than B, comma, A is equal to B, comma, A is less than B. Only one of these also, exactly one of these also, only giving the number system, giving the numbers in a given problem, only one is whole. This is the second one by the statement. And the third one is A is greater than or is equal to B, A is greater than or is equal to B, and B is greater than or is equal to A. A is greater than or is equal to B is greater than or is equal to A. It will give A is equal to B. Or suppose A greater than B. A greater than B means here A greater than B and A is equal to B. Okay. And next one, B greater than A means B greater than A means B greater than or is equal to A means B greater than A implies here B is equal to A. Here B is equal to A. Here also A is equal to B. Here also A is equal to B. We are getting last A is equal to B. In the given statement is saying these three properties. These three properties. I am reading once again the statement. Let A comma B comma C belongs to R. Then first property. If A greater than B and B greater than C, it is implies A greater than C. Second one is exactly one of these roles. A is greater than B, comma, A is equal to B, comma, A is less than B. This is second one. Third one is if A greater than or is equal to B and B greater than or is equal to A implies A is equal to B. This is the statement. Next one, next page I am sharing. Okay, by using this one, we are doing two problems in check your progress, page number 6 here, 1.2.7 here, 1.2.7. By using the above statements and properties, we are doing here, if A not is equal to 0 and A belongs to R, then A square is greater than 0. We want to prove A square is greater than 0. Okay, here A not is equal to 0 means the a number is exist, and A belongs to R means in the real number system, here the real numbers, to taking A is one of the number, okay, and A is not is equal to 0. We want to prove A square is greater than 0. Solution. Here, first of all, A is equal to P, strictly positive number or strictly negative number. Minus A belongs to P. A belongs to P means A is strictly positive number. Minus A belongs to P means strictly negative real number. Okay, either A belongs to P or minus A belongs to P. And the second step is, if A belongs to P, suppose A belongs to P means A is strictly positive number, then A square is equal how much? A into A. A square is equal how much here? A into A. Means it is a strictly positive number into strictly positive number. It will give strictly positive number. Means it is belongs to P. This is the first case. Second case, if minus A belongs to P, means it is strictly negative number. Minus A belongs to means strictly negative number. Then A square is equal how much here? Minus A into minus A. Minus A into minus A is equal how much here? Plus A. It will give A square. It will give A square. Means it is gives a strictly positive number. A square is strictly positive number. Minus A is strictly negative number. But here A square is giving strictly positive number. Okay. Therefore, A square is belongs to P implies A square is greater than 0. This is a 1.2.7 check your progress problem. And next one, 1.2.8 check your progress number. Suppose if x greater than 0, comma y greater than 0, then x less than y. We find only if x square is less than y square. Solution. Here x less than y. X less than y. X less than y means x comma y belongs to P. X comma y is belongs to P. In the previous statement. Okay, x comma y is belongs to P means x is a positive number, y is a negative number. Here x is less than y. It is x is less than y in the problem. And next, if and only if, to prove here x square is less than or is equal to y square. Okay, solution. First of all, x less than y and x greater than 0. X is greater than 0. Multiplying with x on both sides means it is x less than y. Multiplying both sides, x into x less than x into y. Multiplying both sides. Okay, we will get how much it is? X square less than xy. This one, first one. Okay, and next one, take once again take here x less than y and multiplying both sides by y. This is the first equation. This is the first. X less than y, x into y less than y into y. How much it is? Here xy is less than y square. This is 2. Here by using 1 and 2, 1 and 2, how much it is? X square less than xy less than y square. It will give x square less than xy less than y square from 1 and 2. This is check your progress 1.2.8 problem by using the above statement and definition. Okay, I will open one more screen. Okay, next one, definition. One more definition here, absolute value definition. Very, very important definition here. Absolute value definition. Here, let A belongs to R. A belongs to R. The absolute value of A denoted by mod A. Absolute value is denoted by mod A. Okay, here A is belongs to real number set. A is a number, R is the set. A is a number, R is the set. Okay, A is belongs to R, and the absolute value is limited by mod A is defined by mod A is equal to gives plus A. It means A is greater than or is equal to 0. And next one, mod A, absolute value of A is equal to minus A. It is A is less than 0. It is A is less than 0. Okay. Mod A gives here plus A, and mod A is gives minus A. Mod A is gives plus A, and mod A is gives minus A. Means mod A is giving plus or minus A. Mod A is giving plus or minus A. Mod A is called here absolute value. Mod A is called here absolute value. Mod A is equal to first condition A, second condition is minus A. Here the condition is A greater than or equal to 0. Here the condition is A less than 0. Negative number means A is less than 0. Positive number means A is greater than or equal to 0. This is the absolute value definition. Okay. Next one. By using this absolute value, we have 5 results. We have how many results here? 5 results. Here I am not proving this results. Only I am saying here. First of all, modulus of A is equal to here. Modulus of A is equal to mod A is equal to 0. If and only if A is equal to 0. And the second one, modulus of minus A is equal to modulus of plus A for all A belongs to R. And the third one, modulus of AB is equal to modulus of A into modulus of B, comma, for all A comma B belongs to R. This is the third one, third result by using the above definition. And next one, fourth one, it is very, very important one. If a C is greater than or is equal to 0, then mod A is less than or is equal to C. If and only if minus C is less than or is equal to A, less than or is equal to C. And the fifth one is modulus of minus of modulus of A less than or is equal to A, less than or is equal to mod A for all A belongs to R. For all A belongs to R. Here I will explain here fourth one and fifth one. Okay. I am not explaining 1, 2, 3. Okay. Why? Because fourth and fifth are important. Here, first of all, fourth one is C is greater than or is equal to 0. C is greater than or is equal to 0 means C is greater than 0 means strictly positive number, and C is equal to 0 means C is 0. Okay. But I am not taking C is equal to 0. We are taking only C greater than 0. Okay. Next one. Then the value is how much here? Modulus of A, mod A less than or is equal to C. Mod is giving what here? Mod is giving plus or minus C. Okay. Here A is less than or equal to plus C is left hand side. Minus C is left hand side. By using the inequality properties. By using the inequality properties. Okay. Here, first of all, A is less than or is equal to C. Plus A is less than or is equal to C. And here minus A. Here, A is greater than or is equal to minus C. A is greater than or is equal to minus C. By using these two, we are writing here minus C is less than or is equal to A, less than or is equal to C. By using these two, we are writing minus C is less than or is equal to A, less than or is equal to C. Okay. Minus C means it is a negative number. A is a positive number. Okay. And we are writing minus C is less than or equal to A, less than or equal to C. Next one, fourth one, replacing C by mod A. Replacing C by mod A. Here, minus C is less than or equal to A, less than or equal to C in fourth one. Here, replacing C is equal to mod A. Remove C and add mod A. We will get how much here? Minus mod A less than or is equal to A, less than or is equal to mod A. Okay, this is the fifth one. This is the fifth property. By using 4 and 5, we are proving triangle inequality. Next screen. I am sharing next screen. It is completed. Screen is moving. Okay, next one 1.2.11. This is the triangle inequality, page number 7. I am explaining today. Here, triangle inequality. The statement is if A comma B belongs to R, then modulus of mod A minus mod B is less than or is equal to mod A plus R minus B less than or is equal to mod A plus mod B. Okay, this is the statement of triangle inequality. Once again, I am here saying here modulus of mod A minus mod B is less than or is equal to mod A plus or minus B less than or is equal to mod A plus mod B. This is the triangle inequality statement here 1.2.1. Okay, we are proving by using fourth and fifth definition of modulus, definition of absolute value of the results 4 and 5. Okay, we are taking here C, fourth one. If C greater than or equal to 0, then mod A is less than or is equal to C. If and only if minus C less than or is equal to A less than or is equal to C. This is the fourth one. In the place of C, substituting mod A and mod B. Okay, mod A substituting and mod B is substituting in the place of replacing C. Replacing C. Here we are getting here how much here? First one is minus mod A less than or is equal to A less than or is equal to mod A. This is the fifth result. And similarly, replacing C by mod, replacing C by mod B, replacing C by mod B. Minus mod B less than or is equal to B less than or is equal to mod B. Adding these two inequalities, here I am written minus mod A less than or is equal to A less than or is equal to mod A, and minus mod B less than or is equal to B less than or is equal to mod B. Adding these two minus here, this is the adding we will get here minus mod A minus mod B less than or is equal to A plus B less than or is equal to mod A plus mod B. Okay, here taking common here, minus is common. Next step is taking common, minus common here, left hand side, minus of mod A plus mod B less than or is equal to A plus B less than or is equal to mod A plus mod B. Okay, here this is the fourth property. It is seeing like a fourth property, fourth result, page number 7, result fourth one, minus A. Here like minus A is fourth one, minus C, sorry, here minus C, like minus C less than or is equal to A less than or is equal to C. Like these two are same. In the box sign it is. Okay, we can take here, we write mod A less than or is equal to C. పైన ఉన్న దాన్ని ఎట్లా రాయొచ్చు మనం mod A less than or is equal to C అని రాయొచ్చు. దీన్ని ఏ విధంగా అయితే రాసామో mod A less than or is equal to C అని ఏ విధంగా రాసామో పైన ఉన్న రిజల్ట్ కూడా ఎట్లా రాయొచ్చు, ఇట్లా రాయొచ్చు mod A plus B. ఏమని రాయొచ్చు ఇక్కడ బాక్స్ mod A plus B less than or is equal to mod A plus mod B అని రాయొచ్చు. ఓకే, దిస్ ఈజ్ వన్, ఫస్ట్ వన్. రైట్ హ్యాండ్ సైడ్ నేను తీసుకొని ప్రూవ్ చేస్తాను. నెక్స్ట్ లెఫ్ట్ హ్యాండ్ సైడ్ ప్రూవ్ చేయడానికి ప్రయత్నం చేస్తాను. Here taking now here mod A is equal to here minus B is subtracting and minus plus B is adding. A toni minus B and plus B adding and subtracting with the B and a separate bracket A minus B plus B in the mod. Okay, it will give what here mod. It will give how much here mod A minus B plus mod B. This is also one of the triangle inequality. Okay, mod A minus B plus mod B. Okay, here minus B is taking left hand side. Minus B is taking minus mod B taking left hand side. We will get next result here. Minus mod A minus mod B is less than or is equal to mod A minus B. Similarly, mod B is equal to how much here? Mod B is equal to mod of B minus A plus A, adding and subtracting with A, and separate bracket B minus A plus A mod is equal to here less than or equal, not is equal to, less than or is equal to mod B minus A plus mod B. Okay, taking here mod A is taking left hand side, we will get next one. Mod B minus mod A is less than or equal to B minus A. Okay, thus by these two, we will get how much here? Mod of mod A minus mod B is less than or is equal to A minus B. ఈ రెండిటి నుంచి మనము ఈ విధంగా రాయవచ్చు. From this is first one result, this is second one. From 1 and 2, we will get this one. Means here only plus operation and minus operation. Similarly, the other inequality. Here minus is also one of the inequality is there. Plus is also one of the other inequality is also there. Similarly, we can prove, okay, by using this one. And again, I am sharing one more screen. Trying the inequalities for me. Screen is not sharing. Okay, next one, well ordering principle, page number 8 here. Well ordering principle, page number 8 here, 1.3.3 here. By using the definition of 1.3.2, by the definition 1.3.2 is A be a non-empty subset of real numbers. A real number, small a is said to be a least element of A if A is less than or equal to X for every X belongs to A. This is the definition of least element, least element or least number, okay, in a non-empty subset, By using this definition, we are proving here well ordering principle. Well ordering principle statement is every non-empty subset. Here A is the subset and R is the set. A is the subset and R is the set. Here we are taking in the replace R with N. Okay, here it is not I am taking real number system, it is taking natural number system. Okay, natural numbers having least element. Okay, here this is the set, A is the subset. Okay, here the statement is every non-empty subset, here A is the non-empty subset of N has least element, having least element. Suppose A is equal to, suppose here we know the N is equal to how much here? 1, 2, 3 and so on, infinity. And A is equal to, suppose taking 2, 4, 5, 11. Okay, this is the A is the subset of N. A is the subset of N. Okay, here 2 is the least element. 2 is the least element. 2 is the least element means A is subset. A means a subset. Okay, suppose to take here B. Here 4, 8, 11, 30. Here 4 is the least element. Here 4 is the least element. Okay, here B is the subset. The statement is here every non-empty. A is having elements, means it is called non-empty. B is having elements 4, 8, 11, 13. Okay, it is non-empty. Okay, A and B are subsets. A and B are non-empty subsets. A is a subset, B is also one of the subset of N. N is the set. N is the set. A is a subset of N. B is a subset of N. Here A is non-empty subset and B is a non-empty subset. Here it is not it is not empty. It is not empty. It is not empty means it is non-empty. Subset of N has least element. We want to prove least element. Here A is the least element is 2 and B is the least element is 4. Okay. We want to prove by using a general method. By using general method. Okay. Here well ordering principle says here. Well ordering principle says A is subset N and A is not equal to 0. Here, this is the well ordering principle. This is the well ordering principle. Well ordering principle is A is subset N and A is not equal to 0. Suppose A has no least element. A having no least element. A is subset. It having no least element. Define a set of B. Define a set of B like this. N is a natural number such that M belongs to M is also a natural number, comma M is less than or is equal to N. Implies M is does not belongs to A. M is does not belongs to A. I am defining the capital B. One more set. Here A is no least element. A is here a subset. B is also another subset. I am defining N belongs to small n is belongs to capital N such that small m is belongs to capital N, comma here one is less than or is equal to M is less than or is equal to N, implies M, the number M is does not belongs to A. It means B is equal to write down a subset. B is equal to write down a subset. Here B is equal to I am writing here 1, 2, 3. And so on, M comma N comma P comma N plus 1 and so on and so on. Here 1 is belongs to B. Therefore 1 is the least element. Here A has no least element. Here B, subset B is a least element 1. Suppose 1 is does not belongs to B. 1 is does not belongs to B. Then 1 is belongs to A. Least element of A. 1 belongs to A. 1 is does not belongs to A. It implies 1 is belongs to A. It is contradiction. Contradicting the supposition. Because here in the above line, we are said A has no least element. A has no least element. But it is a contradiction. It is a contradiction. Contradicting the supposition of A has no least element. Okay. Next one. I am assuming here let N belongs to B. N is belongs to B, comma M is belongs to natural number set. N is belongs to subset. It is subset. It is a natural number. And the inequality is M less than or is equal to N. It is implies to M belongs to A. This is called what here? This is called what here? The set B. This is called what here? Set B. And N plus 1 also belongs to B. Here N plus 1 also belongs to B. Here N plus 1. N plus 1 also belongs to B. Suppose N plus 1 is does not belongs to B. Suppose N plus 1 is does not belongs to B. Then there exists a number M less than N. It implies to M is less than or is equal to N plus 1. It is implies to M is less than or is equal to N plus 1. M is less than or is equal to N plus 1 and M is belongs to A. Why? Because N plus 1 is does not belongs to B. N plus 1 is does not belongs to B. Yeah. I am reviewing this. Okay. Okay. So here M is less than or is equal to N plus 1. M is less than or is equal to N plus 1. Here N plus 1 is does not belongs to B. Means M is belongs to A. But our assumption is M is does not belongs to A. బట్ యూఆర్ గివింగ్ ఎం ఈజ్ బిలాంగ్స్ టు ఏ. మన అజంప్షన్ ఏంటి? ఎం డస్ నాట్ బిలాంగ్స్ టు ఏ. కానీ ఇక్కడ చూస్తే మనకి ఎం బిలాంగ్స్ టు ఏలో ఉన్నట్టుగా కనబడుతుంది. ఓకేనా? ఎం బిలాంగ్స్ టు ఏ అనేది ఇట్ ఈజ్ ఏ కాంట్రడిక్షన్. ఇట్ ఈజ్ ఏ కాంట్రడిక్షన్. నెక్స్ట్ ఇంకొక దాన్ని కూడా ఇంకొక నెంబర్ని తీసుకుంటాం. ఇక్కడేమో ఫస్ట్ నేను ఏం తీసుకున్నాను? 1 అనే ఎలిమెంట్ తీసుకొని ప్రూవ్ చేశాను. ఇక్కడ 1 అనే ఎలిమెంట్ తీసుకొని ప్రూవ్ చేశాను. ఇక్కడ 1 బిలాంగ్స్ టు బి వచ్చింది. తర్వాత 1 బిలాంగ్స్ టు ఏ తీసుకున్నాను. తర్వాత నెక్స్ట్ ఏం తీసుకుంటున్నాను? n+1 తీసుకుంటున్నాను బిలాంగ్స్ టు బి. తర్వాత n+1 అనేది డస్ నాట్ బిలాంగ్స్ టు బి. ఇట్ ఈస్ నాట్ ఇన్ సెట్ బి. we have got it is the introduction. It is a contradiction. n+1 is belongs to a and m is belongs to a అని మనకు రావడం జరుగుతుంది. It is a contradiction. One more number p belongs to a. To take p belongs to a such that is p is less than n+1. Then here p is does not belongs to n. Then p less than or is equal to n implies p does not belongs to a. It is p does not belongs to a. It is also contradicting. It is also contradicting here. It is also contradicting. And here at last we will get here b is equal to all the natural numbers. B is equal to all the natural numbers, and it will give one is the least element, and it is a is equal to giving a empty set. A is equal to giving a empty set. Why? Because 1 belongs to a. It is a contradiction. n+1 is also a it is also a contradiction number. And p is also we are assuming ఈ p is also does not belongs to a. ఏ నెంబర్ కూడా మనకు ఏలో లేనట్టుగానే కనబడుతూ ఉన్నది. కాబట్టి ఏలో ఏ నెంబర్ ఉంటుంది? మనం అనుకున్న దాని ప్రకారం ఇక్కడ ఏ హ్యాస్ నో లీస్ట్ ఎలిమెంట్ అంటే ఎంటీ సెట్ అవుతుంది. నో లీస్ట్ ఎలిమెంట్ అంటే ఎంటీ సెట్ అవుతుంది. అంటే అవర్ కాంట్రడిక్షన్, అవర్ అజంప్షన్ ఈజ్ రాంగ్. ఏ హ్యాస్ నో లీస్ట్ ఎలిమెంట్ ఈజ్ రాంగ్ స్టేట్మెంట్. A is a subset having no least element is a wrong statement. Therefore, at last we will get A has least element. By using this one, A has least element. This is the well ordering principle. Thank you all of you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, ma'am.
Thank you, sir.
Thank you. ఏమైనా డౌట్స్ ఉన్నాయమ్మా?
Thank you, sir.
హలో,
No doubt, sir. No, sir.
No doubt, sir.
No doubt, sir.